Chapter 8, Arrays, Part 1. Our objectives for this chapter are to learn how to declare arrays and describe what they are, to learn how to initialize an array, to use variable subscripts within an array, and also, in addition to the word subscript, we also use the word index. Index and subscript mean the same thing in this context. We're going to declare and use arrays of objects. We're going to search an array and use parallel arrays. We're going to pass arrays to and return arrays from methods. So first, what is an array? An array is a data structure that holds homogeneous data contiguously in memory. Now, what does that mean? Homogeneous means that it's all the same type. So we can have an array of int, we can have an array of double, we can have an array of strings. We can't have the first element is a string, the second element is an int, the third element is a double, and so on. They all have the same name, but to access each element in the array, we have to use a subscript or index to access each element. So it's holding a list of data, and all data had the same type. So to declare an array variable, it's the same as you would declare any other variable, but we have to use a pair of square brackets. So notice these examples: double square brackets, sales figure, an int square bracket, ID nums. In both of these cases, we haven't specified how many elements are going to be in the array, how many items are going to be in our list, but we have set up the name for the list. And these both are reference variables. We talked about reference variables when we talked about objects, and what's contained in a reference variable is an address. So both sales figure and ID nums would contain the address of the array. Now, because we haven't actually created the array yet, we haven't said how many items are going to be in our list, what's going to be held in both of these references is null because there's no array yet created. So to create an array, to actually allocate the memory, there are a couple different ways to do it. The first way is to say sale. For example, if we had a variable, an array variable named sale equals new, keyword new, allocates memory, double 20. This would create a list, an array of 20 double variables. Another way to do that is to put it all in the same line, say double square bracket, sale equals new double square bracket 20. And 20 again is the number of items in our array. Once you specify how big your array is going to be, you can't change it. That size is fixed. So we couldn't later modify our sale array to have 15 items or 25 items. It's always going to have 20. The subscript is an integer contained within the square brackets, and it allows us to access each element or each item in the list. A subscript that is too small or too large for an array is called out of bounds, and to get a subscript out of bounds error is very common. Any programmer worth their salt is going to have that exception thrown at one time or another. Arrays in Java are zero-based. Now, I know some of you have programmed in other languages before. C++ is the same thing. It uses zero-based arrays. A language such as Visual Basic, at least when I was coding in it 10 or 15 years ago, you could indicate any starting value that you wanted for your subscript. But in Java, all arrays start with a subscript of 0. So let's look at our sale example up here. We'd have sale sub 0 would be the first element in the array, sale sub 1 would be the second element, and sub 2, sub 3, sub 4, and so forth. The last index, the last available subscript for my sale array declared on this slide is going to be 19. So it's going to be the number of elements, 20, minus 1, because we start counting at 0. The first array element is referenced by 0. It might be helpful to think of that as an offset. So sale sub 0 is the first element in the array because it's at the beginning. Sale sub 1 is offset 1 from the beginning. So sometimes it's helpful to think of it in those terms. We already talked about the subscript. When working with any individual array element, treat it no differently than you would a single variable of that type, a primitive variable that we've been using already. Also called atomic variables because they can't be further subdivided. So to access the first element in the cell array, you would say cell sub 0, those square brackets with the index inside are read sub, and then the index is said, so cell sub 0 equals 2100.00. So we're taking 2100 and we're storing that in the first element of the cell array. So here's an example of sales figures, assuming we had declared sales figures to have 20 elements. Our first element in sales figures would be referenced by sales figure sub 0, the second element sales figures sub 1, and so forth, all down to the last element, which is sales figures sub 19. If we attempted to reference sales figures sub 20, we would get an array index out of bounds error, or a subscript out of bounds error. And that's a runtime error. That will cause our program to crash. So there's several different ways that you can initialize an array. It is again a reference type. A variable with a reference type holds an address of where the specific variable value is stored. So array names represent an address in memory, which is another way of saying a reference. When you declare an array name, no memory is assigned, and we saw that on the first slide. We didn't actually allocate memory until we used the keyword new. There's one other way that we're going to access memory that we'll see in a moment. So if you have not accessed any memory, if you haven't used the keyword new, the array will hold the value of null, meaning you haven't allocated any memory yet. So for example, in sales figures that we saw on the very first slide, it didn't say equals new, double, or whatever. It would just have null stored in there until we gave it some value. So, for example, we use the keyword new to allocate memory. So if we wanted to declare an array called sumnums, int square bracket sumnums equals new int 10, that would declare an array of 10 integers and store the address of the first one in sumnums. Because it's an integer, all array elements would automatically be initialized to 0. And the same is true for doubles, that if you declare an array of type double, all array elements will be automatically initialized to 0.0. If you declare an array of type char, all elements are initialized to null. If you declare an array of type boolean, all elements are initialized to false. And if you declare an array of type string, all array elements are initialized to null. So there's another way. This is the second way to allocate memory. You can use the initializer list syntax. So for example, if we wanted to initialize an array of int called 10mult, we could set it equal to, notice that's a squiggly brace. Take a moment to find it on your keyboard. You've seen this to denote a code block in Java. And we could say 10, 20, 30, 40, 50, 60. And it would automatically, Java's smart enough to go, okay, there's 6 integers here. I'm going to make an array of 6 integers. So you don't have to say that you need new int 6. It's automatically going to do that for you. This is called initializer list syntax. And it automatically populates each element in the array with the values in the initializer list. So 10mult sub 0 will be equal to 10. 10mult sub 1 will be equal to 20. 10mult sub 2 will be equal to 30, and so on.